Hi everyone, welcome to this video on lesson 10 of the atomic structure and periodic table scheme of work. I'm not going to do anything in the visualizer for this video because I think actually this is one of those topics that is fine to teach using PowerPoint. The first activity that I've got in this lesson is a kind of card sort, and I think the key idea that you want to make students aware of here is what was it that Newlands and Mendeleev, who we'll look at next lesson, what was it that they were trying to achieve? So we've done loads and loads of stuff on the atom and the way the different properties, especially in terms of electron configuration, affects certain things about how the atom behaves. It's all quite abstract, and I think it's worth just stressing to students that we're going to bring it back now to a time before we knew about electrons, full stop, but certainly about electrons and their energy levels and how the different numbers of electrons in the energy levels affected things. So what we're going to do after these lessons is bring all of that stuff we were doing around electron configuration together with all of this stuff around the periodic table and kind of achieve this grand synthesis where we can explain the reactivity of different metals and different halogens and so on in terms of their electron structure. Anyway, I'm waffling here. Let's recap. The point that you want to stress to students is to say there was this point in time where scientists knew about various elements, they knew about different materials, things like gold and silver and mercury and other metals, as well as some of the gases. So they'd kind of picked out by this point hydrogen, oxygen, nitrogen, and so on. So we knew about this stuff, but we had no idea how they could possibly be organized. And there was no sense that there might be a pattern that would explain why these different materials are different. And this is what Newlands was trying to achieve. He was trying to find out some sort of pattern. So the first thing you can ask students to do with this card sort is, once they've kind of cut out all the cards, just ask them, okay, how do you arrange these? And the point you want to get across first is that the most logical way to arrange them, when you know about some of these different elements, the most logical way to arrange them is in terms of chemical properties. So you might say, okay, look, the first thing that I'm going to do is say, well, silver and gold, they both are kind of shiny and unreactive. I'm going to organize those together. And this was what scientists tried to do, but there was no kind of, there was no obvious pattern beyond that. It was just kind of, oh, these random ones happen to behave like this. These random ones happen to behave like this. There was no sense of how they all fitted together. Then the next thing that you want to do in this lesson is say, okay, now that you've probably got chlorine and fluorine together. You've probably put helium and neon or argon. I can't remember all the elements in the card sort. You've probably put gold and silver together and so on. Now, in the next slide that you'll see in the slides there, now you've been given some new information. Someone has found a way of measuring what we call atomic weights. So how are you going to arrange them then? And what you want them to do is start to say, okay, now we should arrange them in atomic weights. That seems like quite a sensible thing to do. But then how could we combine that with keeping the ones with chemical properties together? And what you want them to do is start thinking about how they would bring those two ideas together and end up with something that hopefully looks a little bit like Newlands' periodic table. And then you can say, well, Newlands had this big guess, this kind of big idea. By doing this, he said, well, hang on, maybe there's something about every eighth element. And if we organize our periodic table by every eighth element, we'll see that actually they have similar chemical properties, ordering these by atomic weight. So that's what you can highlight to them. And one of the things that you would like to look at is that some of the elements that students have grouped together in their card sort, hopefully they should see that those have been grouped together in Newlands' periodic table as well. So you can then talk about, okay, this was what Newlands was trying to achieve, and he had this big idea. The problem Newlands had is that not all of his predictions, what you would expect to happen, really worked. So he put, for example, hydrogen, fluorine, and chlorine together, But there's a problem there because actually fluorine and chlorine react very differently to hydrogen. So he came up with this big idea, but it didn't quite explain exactly. It didn't quite match. Not all of the elements, every eighth element, really reacted in a similar way. Now, what we'll find out next time is that the picture was more complicated than Newlands realised. There were elements that hadn't been discovered, and he was a bit premature in coming to these conclusions. So this is kind of a preliminary lesson that really helps show students the genius of Mendeleev in the next lesson. So that's what we can cover. Now, in terms of there's a couple of videos in there which I think are worth showing, which is to say, well, okay, if Newland's guess was true, and we're coming back to these ideas around guess, deduce, check that underpin our whole science curriculum. But if Newland's idea was true, then what would we expect to happen? Well, we'd expect these elements to have similar chemical properties. And I've put some videos in there to show that actually this isn't the case. You might even wish to demo some of these and really show students. Some of them are maybe not safe for the lab, but some of them are possibly doable. So that's one thing you could do to just make what sometimes feels like a bit of a dry, abstract topic a little bit more real to students and also really stimulate some interesting thought. But again, the big idea that I would stress to students in this lesson, they need to cast their mind back to a time before all that stuff we did about electrons, when we really have no idea about how all of these things fit together. So that would be the one thing to stress, and then we'll get a bit closer to our modern picture in the next lesson, which is on Mendeleev.